Welcome to Foundations of Computer Networks. This is session 13, and we want to have a look at how do we go about subnetting a Class B IP address. We have expanded our table to include the Class B IP addresses. So note we have Class A and we have Class B information in the table as well. Class B, by default, it uses 16 bits for the network. Class A, by default, it uses 8 bits for the network. So we're looking at 8, we're looking at 16. Class C, by default, it uses 24 bits. So the values that we have underneath bit 7 to bit 0, that is going to be the side notation for each of the classes of IP addresses respectively. So here goes. The IP address that we are looking at in this example is going to be 172.16.5.45. We are using a side notation of /22, and we want to compute which subnet this particular IP address falls into. In other words, we need to determine the subnet range. What's the network ID? What's the broadcast ID? And then we know that between that are going to be the IP addresses which are allocated to that particular subnet. In order to begin our exploration, let's just look at the fact that a Class B IP address has 16 bits which are allocated to the network portion, which means 2 to the 16 is going to give us the total number of patterns that we are going to have. So we have a little bit over 65,000 networks that we can create using a Class B address. Incidentally, for Class B, by default, the number of host bits and the number of network bits are going to be the same, because we are working with 4 octets. Each octet has in 8 bits, so 8 4 is 32. So if we allocate 16 to the network, then it means that 16 are going to be left to be allocated to the host. So in terms of the networks, we have 65,536 networks, and for each of these networks, we have 65,536 IP addresses which can be allocated to the network. Alright, so having gotten that out of the way, remember we are now doing subnetting, which means we are going to borrow some host bits so that we can create subnets. So the default subnet mask for Class B is going to be 255.255.0.0. That's what we know. But given the side annotation /22, that is telling us that we are borrowing some of the host bits. So we need to determine which octet we are actually working in. And the octet that we are going to be working in, saying that this is a Class B IP address, it means that we are now going to be working in the 3rd octet. So we know that the first 2 octets are all being used for the network portion. So if we are going to borrow host bits, we are now going to start borrowing host bits from octet 3 or the 3rd octet. So /22 falls at this position, and if we turn on all the bits up to that point, then we end up with 1 1 1 1 1 1. So that is 6 bits. 1 2 3 4 5 6, and it means that the other values are going to be 0 and 0. Let me turn on, use a different color here. So there we go. So we have turned on all of those bits. And if we now look at the subnet mask that is associated with this, it's actually going to be 252. So it means that the new subnet mask is going to be 255.255.252.0. Now this tells us something very specific. It tells us that the octet that we are working with is the third octet. Therefore, the subnet differences are going to be expressed in that third octet. That's how we will know when we have changed or moved between the different subnets. Let us now do our computations for the subnet and the host. So in other words, how many subnets are we creating? Well, we have 6 bits, which we have borrowed for the subnets. So therefore, it means that 2 to the 6, and that gives us 64 subnets. So we have 64 subnets. Alright. And the other question that we need to ask is, how many hosts are we talking about? So there are 2 hosts here. But remember, this is the third octet. So it means that the fourth octet, we're also going to have all of those bits being set to 0. So it's 8 plus 2 that gives us 10. So 2 to the 10 tells us that we have 1024 IP addresses within the range. So 1024 IP addresses. So let's quickly rehash what we are doing, or what we have done. We have taken a class B address range, total range, and we have divided it into 64 subnets. And in each subnet, we are saying that the number of IP addresses that we have in a subnet is going to be 1024 IP addresses. So that's what we have effectively done so far. What we now need to do is to determine the ranges for these IP addresses. In other words, what are the subnet ranges? Alright, so let me go here. No, sorry, let me come here. And we start out by determining what remains constant. Class B IP address, 16 are being used for the network ID. So it means that all the network IDs will start with 172.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168.168. that is where the range actually starts. So it's 172.16.0.0. So we are now going to compute the different subnets that we can now get, starting from that particular IP address. So the next thing that we need to then determine from our table is what is the increment size. And if we go back to our table, and if we look above the 255, which is the subnet mask, then it tells us that the increments are going to go up in terms of 4. So you might see it in your notes as being the block size. In some notation, some other documentation, you might find it as being the group size. So that is what tells us when we are now inside a different subnet. Please bear in mind that we are working in the third octet. So it therefore means that the next subnet is going to be 172.16.4.0. And it means that the one after that is going to be 172.16.8.0. And the one after that is going to be 172.16. And then 8 plus 4, that gives us 12.0. So I hope you have now seen the pattern in terms of how the IP addresses are now moving down and how they are changing. So we wanted to determine which subnet 172.16.5.45 falls into. And if we have a look at the IP addresses that we have so far, then we should easily see that it's going to fall between 172.16.4.0 and 172.16.8.0. So it has to fall within that range. Now, because 172.16.8.0 is a new network, then it tells us that this IP address that we're looking at is supposed to fall into the 172.16.4.0 network. So we now need to determine what the ending range for these IP addresses, or for these subnets, is going to be. Let me change the font on this. So this is 13. And let me scoot over these values. So that I can get some space for what we need to do here. Alright. So this next network begins at 172.16.4.0. It means that we need to subtract 1 from this to determine what the ending range up here is going to be. So we know it goes to 172.16, and then we now need to determine what is one IP address before 172.16.4.0. So this is going to be .3.255. Now, how did we end up with 3.255? Well, remember, each octet goes from 0 to 255. So whenever we reach 255, that is the last item or the last value in that octet. And if we now increase it by 1, then it means that that octet goes to 0. So 255, if I increase it by 1, it becomes 256. We cannot represent 256 using base 2. So it means that we put a 0 in that position and we carry over a 1. We carry over a 1, then 3 plus 1 would now give us 4. Which means that the next IP address after 172.16.3.255 is going to be 172.16.4.0. So please bear that in mind. Each of these octets range between 0 to 255. Once we reach 256, we cannot represent that within any of these octets. So what we do is we put a 0 at that position and we move a 1 over to the next column, and we add that 1 to that particular column. By that same extension, therefore, it means that the ending range for this one is going to be 172.16.7.255. And the one for this is now going to be 172.16.11.255. Alright, so we know, therefore, by looking at the IP address that we were given, that this IP address should fall within this particular range. So it should fall between 172.16.4.0 to 172.16.7.255. Alright, great. So we have computed the IP address range, or the subnet, that this particular IP address is going to fall into. For clarity though, let's just do something quickly. And what we're going to do is we're going to determine how many IP addresses we said are within each of these subnets. And going over here, we had computed the fact that we'll have 1024 IP addresses within a subnet range, which means that this entire subnet range that we have just looked at should give us 1024 IP addresses. We're going to check that out, but we're going to check it out by using the one above, as it might be a little bit easier to understand. So the first IP address we know is 172.16.0.0, and if we look at the increment size we had identified to be 4, because we are using a /22 CIDR notation. So the increment is 4. We have also determined, because we are using a class B, that we are making changes to the third octet. So it therefore means that 172.16.0.0 is the first range that we're looking at in that octet. Then we would move to 172.16.1.0. And if we ask ourselves for the first IP address, this one, how many valid patterns do we have? Then we are going to end up with 256 patterns. So 256 patterns. How do we know? Just give me a second. Something looks odd here. Alrighty. Alright, let's do it that way. Let me change this color. Alright, so we have 256 patterns. How do we know that? Well, if we look at the last octet, that is, or that can hold 256 patterns. Why? There are 8 bits over there. 2 to the 8 give us 256. When we count up from 0 to 255, remember 255 is the last value that can hold in that octet. And when we go to 256, then it means that we now put a 0 in that position. So we're now looking at this IP address. There's a 0 in that last octet. And we increment the previous column by 1. So it moved from 0 to 1. So it means that we can accommodate 256 patterns there. It also means by extension we can have 256 patterns there. And remember, we had said that we have 4. So the increment was 4. So we'd have to do this 2 more times, meaning 172.16.2 and 172.16.3. So it means that for each of these we have 256. And if we add up all of this, well, 256 times 4, remember multiplication is a quick way of doing addition, right? And we end up with 1024. So just for completeness, this is going to be 2.0 and this is going to be 3.0. So it therefore means that this one here, if we were just looking at the total IP addresses within that particular range, it's going to be 172.16.0.255. Did I put on the 255? Yes, I did. I don't have my bar here, so let me just drop this somewhere else. Alright, so there we go. And this one is then going to be that straight up to 255. And then the other one is going to be similar. Straight up to 255 again. And then this third one is going to go up all the way to 255 again. So what we were saying earlier, if I just grab this as well, bold, and let me increase the size a little bit. So what we are saying here is that between 172.16.0.0 and 172.16.0.255, that gives us 256 patterns. So there are 4 of these bands that are going to be associated with a subnet. Therefore, it's 256 times 4, which accounts for the 1024 IP addresses which are found in one subnet. Because a subnet, we had determined it moves up by 4. So all of this would define one subnet, the first subnet. Which means that we would have now done something similar for the 172.16.4.0 network. So we would have 172.16.4.0, would have .5.0, .6.0, .7.0. Those are now going to be grouped together to form the second subnet. Alright, so let's quickly jump to another example. But before we do that, I want to show you a technique that you can use to quickly identify the network ID for a particular IP address so that you can know which subnet it actually falls into. So by having a look at this IP address 172.16.5.45 with a /22 side annotation, we have determined that it should fall into the 172.16.4 network. And we came to that conclusion by going about it in a rather elaborated format. But there is a technique that we can use that can simplify things. And this is where the subnet mask comes into play. So we know that the subnet mask for the /22 is going to be 255.255.252.0. And it's in that third octet that we are doing the subnetting. And if we convert that 252 to decimal, then we end up with this pattern here with 6 1s and 2 0s. So we are going to make use of that. So I'm going to put back that subnet mask over here, and I'm using the little dash just to separate the groups of 4 so that it is easier to see. So we have 1 1 1 1, and then we are going to have 1 1 1 1 0. So that's the subnet mask. We are now going to have a look at our IP address, and because the subnet mask affects the third octet, then we are going to take the third value out of the IP address, which is the 5, and we are going to convert that to binary. So if we convert 5 to binary, using the 8 bits, then it's going to be 0 0 0 0 0. So that's 5 zeros, 1 0 1. So 4 and 1 gives us 5. So let me write that on top of this. So that's 0 0 0 0 0. I think it's 5. And then 1 0 1. So let's get this format thing and place it here. So this is 5 expressed in binary. So what we're now going to do is we're going to use the AND operation on this, and we are going to see what we end up with as our result. So I'm just taking the formatting, and let me change that color to black. Alright, so 0 and a 1 give us 0. So remember, whenever we are doing AND, the only time it is true is when both things are true. So we can quickly compute that for the first 4, it's going to be 0 because we see a 0 somewhere there. So that's going to end up giving us 1, 2, 3, 4 zeros. And if we now look at the ending, then it's going to be 0 1 0 0. So that's 0 1 0 0. So this is what we end up with when we AND them. By the way, for this intent and purposes, if you're not sure what the AND does, then just pretend that you are multiplying the two values. So 0 times 1 give you 0, 0 times 1 give you 0. The only time we would get a 1 is if we say 1 times 1, and that would give us the 1 there. Everything else is going to be 0, because if we're multiplying the two values, then once there's a 0, then it means that the multiplied value becomes 0. So we end up with this pattern here. And this pattern here, if we convert it to binary, so if we put it back under here, then this would be 0 0 0 0, and then 0 1 0 0. And if we look to see what this equates to, only one thing is turned on. It's a 1. It gives us a 4. So it tells us therefore that the network ID is 172.16.4. And then we know that we're going to put a .0 at the end. Alright, so let's do one more quickly. So this time let us do 172. Let's say 16.25.1.3. So remember, we are working with the same /22. So the same /22, let me just put it there for completeness. And now we are being asked to determine which network, which subnetwork this IP address falls into. So one way to do it is to sit down and write out all of the ranges until we reach 25, something that will hold 251, which is going to be a lot of writing out. Remember, we have 64 subnets, so that's a whole lot of writing out. Or we can use a technique that we just looked at. So we know that the subnet mask is right here. So what we now need to do is to compute what 251 is in terms of binary, and we put it here, and then we do the AND between the two, and whatever we end up with, we convert that back to decimal, and that should tell us where that particular thing is going to lie. Alright, so the question is, what is 251 in binary? So we want to find what is 251 in binary. Alright, so we start out with 251. And we know that we can get 128 from that. So we subtract 128. And that leaves 123. So let me get rid of this. So we get a 128. It leaves 123. And from that 123, we can get a 64, right? And that leaves 59. So we got a 64. It leaves 59. Well, we can get a 32. So we get a 32 from that. Leave 27. Well, from 27, we can get a 16. So let's get a 16. So we got a 16. That leaves 11. Well, from the 11, we can get a 8. So let me put that there, and we take the 8. And that leaves 3. It therefore means that we cannot get a 4. But we can get a 2. And we can get a 1. And that gives us back the 3. So we get a 2. And we get a 1. That carries us down to 0. So it therefore means that the binary pattern that represents 251 is going to be this binary pattern here. So let's put that pattern up here. So we have 1 1 1 1 underscore, and then we have 1 0 1 1 1 0 1 1. Now we need to AND these two values. So if we AND these two values, then we are going to get 1 1 1 1 1, then 0 0 0. So that's going to be 5 1s and 3 0 in that order. So we have 1 1 1 1. We have one more 1, and then everything else becomes 0. So what do we now do is to take this value, and we then determine what this value is going to be. So if we take this value and we we add up all of these bits, then it means that we are going to have 5 bits under the, well, let me just show you. So it's going to be 1 1 1 1 1. That's 5 bits, and then 3 zeros. And remember, we had done a little table that will allow us to quickly add up all of this. So we know that if we add up all of this, then it's going to be 248. So what does this tell us? Well, this tells us that this particular IP address that we are looking at actually belongs to, where can I write this? Let me put it here. 172.168.248.0 network. That's what it belongs to. So it belongs to the 172.168.248.0 network. So what's the network that would fall after this network? Well, remember, we are saying here that the increment size is 4. So it therefore means if we add 4 to 248, so this is equal to 248 plus 4, that carries us to 252. So it means that the next network would be 172.168.252.0. And if that is the case, then it means that this network here would have to be 1 less than this one. So going by what we had done earlier, then this is going to be 172.16. So 172.16. And then remember, this thing here is 252.0, so we need one less than that. So it's going to be 251.255. Remember, 255, if we add 1 to that, it becomes 256. So it therefore means that this now becomes 0. And then we carry over 1. So the 251 now becomes 252. That's what we were saying earlier. So therefore, we know that the IP address range, or the subnet range, is going to range from 172.16.248.0 to 172.16.251.255. And it is in that subnet that we would find 172.16.251.3 IP address. Remember, once again, we are using a /22 side annotation. So I think this has been a lengthy video, but I think that we have covered the essentials of subnetting, and what we have just done to a class B address can also be applied to a class A address, and so on. So please take some time to go through this video. Please grab your pen, your pencils, paper, and as you rewatch, pause often, do the calculations or the computations for yourself. And once you do that, and you do it a couple of times, then all that I've been saying here will become almost second nature for you, and then you will be able to address or take on different kind of problems. Now, one of the things that I'm going to do is to do up a tutorial sheet in terms of subnetting with some class A, some class B, and some class C IP addresses, maybe 3 each. And then I will put it up so that you can have a look at it, do your computations, and then we will have a session where we will work them out together, and you can then double check your answers, and we can have some dialogue to further clarify what has been done here.